Okay, so today, as I told you, we'll start with the math syllabus. We have linear algebra in that. Then we have calculus. Then we have the differential equations and some special topics. So linear algebra will be your matrices, system of linear equations, rank of a matrix, eigenvalues, eigenvectors, and like that. Calculus will be for functions of single variable, limits, continuity, differentiability, partial derivatives, maxima, minima, like that. And also it will also have your vector calculus. In that you will have integration, line, surface, and volume integrals. Then you will have the theorems of Stokes, Gauss, and Green, right? Your differential equation will be of ordinary differential equation and partial differential equation, and some special topics like Fourier series, Laplace transformations, numerical technique, complex. Okay, so these are your topics, and your marks will also be distributed in that way as well. So matrix will come for around, like linear algebra will be for around 2 to 3 marks in your paper. Differential calculus comes around for 2 marks. Differential calculus comes for around 2 marks. Then again, ODE, PD will come for around 2 marks. Then Laplace you will have for around 1 to 2 marks. Numerical technique generally around 1 mark. Fourier series we have it sometimes we don't have it, so it will come from 0 to 1 mark. And vector calculus will also come for around 1 to 2 marks, right? So today we are going to start with differential equations. That is your first order linear and non-linear differential equations. Okay. So we'll start today with the ordinary differential equation. Now, what is a differential equation? Simply like dy by dx is equal to some cot x. That is your differential equation, right? So differential equation is an equation involving a dependent variable, an independent variable, and the differential coefficient of the dependent variable with respect to the independent variable. So that is the definition of a differential equation. Now there are types of differential equation. One is the ordinary differential equation and another is the partial differential equation. So ordinary differential equation and partial differential equation. Now, of course, you guys know about this, right? In your fluid structures and all other subjects as well, you have the differential equations. Like any equation that is in the form of dy by dx, that will be your ordinary differential equation, and any equation that is in the form of dou z by dou x. Suppose z is a function which is dependent on x and y. So we have two differential equations like dou z and dou x, when y is a constant, and dou z by dou y when x is a constant, right? So if I have an equation in the form of x dou z by dou x plus dou z by dou y of y equal to z, then this will be a partial differential equation. And if I have simply an equation dy by dx, x square or something, x dy by d square y by dx square equals to 0, this will be my ordinary differential equation, right? So ordinary differential equation is one that involves one independent variable, is called an ordinary differential equation. So you just have one independent variable. Okay. So all of you know this equation from structures. Mx double dot plus Cx dot plus Kx is equal to something. Okay. That is some function given to you. Even if you don't know, we'll not go into structures. This is a normal differential equation given to you, which means m d square x by dt square plus c dx by dt plus kx. This is some equation where your x is the dependent variable and t is the independent variable. This generally means that x is a function of t, right? Okay. Now, very important thing for differential equation is what is the order of a differential equation and what is the degree of a differential equation. So very important thing is order and degree of a differential equation. Okay. So the order of a differential equation is the order of the highest order derivative. This is the order of highest order derivative. In the differential equation. So suppose let's take this differential equation. Right? So let's take this differential equation. Now, order of the highest derivative. Order of the highest order derivative. So which is the highest order derivative here? D square x by dt square is the highest order derivative, right? And what is its order? Its order is 2. Its order is 2. D square x by dt square. So its order is 2. Now let's come to degree. Degree will be the degree of the highest order derivative. Degree will be degree of the highest order derivative when made free from any radicals. When made free of any radicals. So what are radicals? Radicals will be like square root or cube root, like that. Okay. So here in this equation, there are no radicals, right? So what is the degree? What is the degree of this? Degree is 1, right? It is just d square x by dt square. It is nothing like whole square or whole cube or anything, right? Its degree is 1 over here. So degree of this equation will be 1. So order of this equation is 2 and degree of this equation is 1, right? I hope this is clear. This is a very, very simple concept. So let's take one differential equation. For example, d square y by dx square plus square root 1 plus dy by dx the whole cube equal to 0, right? So this is a random differential equation given to you. Now your task is to find the order and degree of this differential equation. So the very first thing is, I can see a radical here, the square root. First thing is I have to get rid of this radical. My equation should be free from the radical signs and fractional power, right? So just simplifying it, taking it on the other side, it will be 1 plus dy by dx whole cube. Now, I need to get rid of the square root sign. So I'm simply squaring on both the sides. So what do I get with that? D square y by dx square, the whole square is equal to 1 plus dy by dx cube. Now, can anybody please tell me what will be the order of this differential equation and what will be the degree of this differential equation? You can write it in the chat box, please. Yeah, so please write your answer in the chat box. What will be the order of this differential equation and what will be the degree of this differential equation? Okay, so I have so far got 1, 2, 3 answers. Yes, please. Others also please reply. Yes. So I feel everybody has understood this concept. Okay. So order of the differential equation will be order of the highest order derivative, that is d square y by dx square, and its order is 2. And degree of the differential equation will be degree of the highest order derivative, that is also 2. So order is 2 and degree is also 2, right? That's good to see that everybody is clear with this concept. So now with order and degree, we have one more basic thing, that is whether the differential equation is linear or not. Whether the differential equation is linear or not. Okay. Now here, the differential equation is not linear if it has a derivative or its dependent variable in multiplication. So if you have something like x, but you have something like x dx by dt, you have something like dx by dt whole square, right? Or if you have dx by dt into d square x by dt square. If you have any of these terms in your differential equation, then it is non-linear. Let's see our original differential equation that we took, for as an example, m d square x by dt square plus c dx by dt plus kx. Guys, please tell me whether this is a linear equation or not. Is the dependent variable or its derivatives, are there present in this, in any term in multiplication? No, right? No. So it is a linear differential equation. So it's a linear differential equation, right? So what about this? dy by dx is equal to cot x, the first example. What is this? Is this a linear differential equation? Okay, I'm getting one answer, two answer. Please, others also please reply. So this is also a linear differential equation. Yes. So this is also a linear differential equation. Now, this was whether the differential equation is linear or not. Next thing is whether the differential equation is homogeneous or not. To check whether a differential equation is homogeneous or not. So differential equation will be a homogeneous differential equation when each term has dependent variable. When each term has dependent variable. Each term has dependent variable and the equation is equal to 0. And the equation equal to 0. So suppose we'll take our basic equation md square x by dt square plus c dx dt by dt plus kx equal to 0. So please tell me whether this is a homogeneous equation or not. Yes. So it will be a homogeneous equation. Homogeneous equation. Now if I'll suppose write this as equal to 10. Now please tell me whether it is a homogeneous differential equation or not. No, it's not a homogeneous differential equation, right? If suppose I'll also write it as this plus kx term, I'll simply write it as plus k equal to 0. Now tell me whether it is a homogeneous equation or not. No. Why? Because this is a constant and you do not have the dependent variable in each term. So you have it in this term, you have it in this term, but you don't have it in this term, right? So it is not. So just as an example, d square y by dx square plus y equal to 0. Please tell me its order, its degree, whether it is linear or not, and whether it is homogeneous or not. Come on, please tell me, guys. What will be the order of this equation? First thing, what will be the order of this equation? What is the highest order derivative here? It is d square y by dx square, right? So its order will be, yes. So its order will be 2. Then what is the degree of this differential equation? D square y by dx square is the highest order term. So what is its degree? 1. So degree will be 1. Yes. Okay. Then whether it is linear or not, please see if it is linear or not. So this is what about its dependent variable? Please tell me whether it is linear or not. Yes, it is a linear differential equation. And also it is a homogeneous differential equation, right? So it is linear differential equation as well as homogeneous differential equation. Now suppose if I'll say y equal to x dy by dx plus dy by dx the whole cube. Please tell me whether this equation is linear or not. Yes, so this equation is non-linear because of this term. Which term is this? Dy by dx the whole cube. That means the derivative of the dependent variable is in multiplication 3 times. So hence this is a non-linear differential equation, right? So here please note down very important thing that also please note down this. What will be the order of this differential equation and what will be the degree of this differential equation? The order of this differential equation dy by dx is 1. Order of the differential equation is 1. Yeah. So linear and non-linear. So linear will be as I have told you here as well. See, linear will be if any of the terms are in multiplication with the dependent variable or its derivative. So if it is, suppose x is your dependent variable and you have a term like x square, so it is non-linear. X is the dependent variable, and if you have a term like dx by dt, then again it is non-linear. If you have a term like dx by dt whole square, then also it is non-linear. Why? Because you have dx by dt multiplied twice. Okay. So if your dependent variable and its derivative is in multiplication in any one term of the differential equation, then it is non-linear. So here in this example, as we can see, this is the term that makes it non-linear. And here, yes, so in the first term, it is x dy by dx. See, please note here that y is the dependent variable and x is the independent variable here. So x into dy by dx is not a problem. Okay. So this term is linear, but this term is non-linear because you have dy by dx into dy by dx into dy by dx. Is it fine? So this equation becomes non-linear. You just need to see what is your dependent. First thing is, what is your dependent variable, what is your independent variable, and then you have to check whether your dependent variable is in whether your dependent variable or its derivatives like dy by dx, d square y by dx square, something like that, are in multiplication of each other or not. All the terms should not have the multiplication of each other. Okay, then the equation will become a linear equation. Otherwise it is a non-linear equation like this one. Now here we'll come to order and degree. So what is the order of this differential equation? Our highest order derivative is dy by dx only, right? It is dy by dx. So what is the order of differential equation? Order is 1. Now what about degree of this differential equation? Now degree of this differential equation will come from this term, dy by dx whole cube, right? So degree of this differential equation is 3. Yes, so degree of this differential equation is 3. Now very important thing to note here will be that whenever degree is greater than 1, the equation will be non-linear. The equation will be non-linear. Now, why I didn't tell you this in the beginning? Because I wanted you to understand the logic behind it. Whenever degree is more than 1, that means either d square y by dx square or some term like that is having power 2, right? Or power 3. Or so, like in this case, it was dy by dx having power 3. So whenever the degree is more than 1, it is directly a non-linear equation. But if you have but if your degree is 1, then you need to check it properly. Okay. But if your degree is more than 1, then you can directly say that it is a non-linear equation. Right? Fine. Okay, now please, you only try to do one of the numerical here. I'll just give you one example. Just tell me what is the order, what is the degree. Rho equal to 1 plus dy by dx the whole square 3 by 2 divided by d square y by dx square. Now please tell me its order, its degree. So first thing that we are seeing here is that this equation has a radical 3 by 2. So first thing we have to do is get rid of this radical 3 by 2 power. What we'll do? We'll do squaring on both the sides. So it will become what? Rho square equal to 1 plus dy by dx the whole square cube divided by d square y by dx square. Right? Right? Then I'm just simplifying it. So rho square d square y by dx square equal to 1 plus dy by dx the whole square cube. Now please tell me, sorry, this will also become square, right? Yeah. Now please tell me, what is the highest order derivative here? My highest order derivative will be d square y by dx square, right? So highest order derivative is d square y by dx square. So its order is 2. Now, what is the degree of this highest order derivative? So degree of this higher order derivative is also 2. So order is 2 and degree is also 2, right? I hope this concept is clear with everyone. Let's just see one numerical. Fine. So please solve this numerical. So the equation given to me is d cube y by dx cube plus 4 square root dy by dx the whole cube plus y square equal to 0. So this is the equation given to us. Now please find out what is the order and what is the degree of this differential equation. Yes, your answer is correct. Please find out what is the order and what is the degree of this differential equation. Yes, I got few answers. What about others? Yes. So here the order of the differential equation will be, what is my highest order derivative here? Highest order derivative is d cube y by dx cube. So it will be 3. Right? Now degree of this highest order derivative. Okay, first thing is to get rid of the radicals. So okay, fine. Let us get rid of the radical. But you can also calculate it directly if you want to, because the highest order derivative is d cube y by dx cube, right? So d cube y by dx cube equal to minus 4 square root dy by dx the whole cube plus y square, right? Now squaring on both the sides, I'll get this square and this will go, this will become square and this will become minus 4 square, right? So d cube y by dx cube will be, so order I can tell without even removing the radical, of course, right? D cube y by dx cube will be 3. So my order is 3 because this is my highest order derivative will remain same, whatever the power may be. So order is 3. And what about degree? What is the degree of this highest order derivative? It is 2. Yes, you are correct. So degree is 2. So order is 3 and degree is 2. Right? So order is 3 and degree is 2. I hope everybody is clear with this. Then, now, which of the following equations is a linear ordinary differential equation? So linear ordinary differential equation, you know that as you can see here, y is the dependent variable. So there shouldn't be any term that has y into y, or it has y in multiplication of derivative, or the derivatives are multiplied with itself, right? So please see here in the first option given to us. So d square y by dx square, that is fine. Plus dy by dx, that is also fine. But we have here a term 2y square. So that is y into y. So please tell me, this is linear or non-linear? Yes, so this is a non-linear differential equation. Yes, so it is a non-linear differential equation. Now come to the next one. In option B, we have d square y by dx square plus y dy by dx plus 2y. So here, yes, your answer is correct, Dev. So here we have y dy by dx. Y dy by dx. So this is also a non-linear differential equation because the dependent variable is in multiplication with its derivative, right? Come to see d square y by dx square plus x dy by dx plus 2y. Now please look here, the term is x dy by dx. So x is an independent variable. So this is a linear term. Okay, don't get confused with this. This is a linear term. So your answer is C. This is a linear differential equation. Also, we can check option D, dy by dx whole square. So first thing we got dy by dx whole square. So this term makes it non-linear. I hope this is clear with everybody. Yes, I hope this is clear with everyone. So then we'll move towards our next topic, that is solution of a differential equation. That is solution of a differential equation of first order and first degree. So we'll do different types. We'll start with the basic one, that is solution of differential equation for the first order. Okay. Here we learn the first type. There are many types to solve these differential equations. First type will be variable separable form. So you are given a differential equation, but now you need to solve it. You are given a differential equation and now you have to solve it. So we have to find the solution. Generally, there are two types of solution. That will be a general solution and a particular solution. General solution will be the solution which will have the arbitrary constants, which will be actually a complete solution, right? And particular solution will be the one which you will get by giving the particular values to your arbitrary constants. You will get that by giving values to your arbitrary constants, right? So let us come to the first form, that is the variable separable form. Very easy and very important for your exam, because this will come, like this comes in your exam many times, like it is a repeated question. This form is repeated, this type, variable separable form. So let's see what it is. The equation of this type, any differential equation, any given differential equation of this type can be put in the form of f1x dx equal to f2y dy. So if you look carefully on both the sides of the equation, you can see on one side you have all the x terms, and on the other side you have all the y terms, right? So these are variables x and y that are separated. So it is a variable separable form. Now such equations can be solved immediately by integration, and the solution is given by integration of f1x dx equal to integration of f2y dy plus some integration constant c, right? It is an arbitrary constant c. I hope this form is clear, this type is clear. Now it will be on you that you will be given a numerical in the exam, and after learning all the types, you will see which type, like this, okay, this equation I can solve it with help of this type. So this equation will be solved with variable separable form, right? So let's just try one numerical. It will become more clear with it. So let's just try one numerical, simple. Solve dy by dx equal to 1 plus y square divided by 1 plus x square. Dy by dx equal to 1 plus y square divided by 1 plus x square. Now looking at this equation, we can say that we can separate it in the form of y and x, right? We can separate it in the form of y and x. So how we can separate it? So separating the variables, we get dy, I'm just taking 1 plus y square this side, and dx over 1 plus x square, simply, right? Fine. Now how to find its solution? We have to integrate on both the sides. So integrating, so what will be the integration of dy over 1 plus y square? Simple, it will be simply tan inverse of y equal to tan inverse of x plus some constant c. To write that constant in a better way for our numerical, we are going to put constant c as tan inverse c, right? Or if you have a numerical with log terms, then we'll put the constant as ln c, right? So that we can simplify our solution, because constant c or tan inverse c or log c, all are arbitrary constants only, right? So it doesn't matter, but it will be helpful for you to get a proper solution. Okay. Now, can I say this, that tan inverse y minus tan inverse x equal to tan inverse c? Can I write this as, so what is tan inverse y minus tan inverse x? You have a formula, right? Tan inverse a minus tan inverse b will be b minus a over 1 plus ab, right? So this will become tan inverse b minus a. So here it will be y minus x over 1 plus xy. equal to tan inverse C. So this will become y minus x over 1 plus xy equal to C. Removing tan from both these sides. So this is your simple trigonometry, right? So this is the solution of your differential equation. Right? Then please note it down and we'll do one more numerical then, so that the concept is very clear. So let's move on to the next numerical then. So find the solution of a first order differential equation x dash t equal to minus 3x t where x naught is x0. X naught becomes x0. So this is given to you. Your differential equation is x dash t is equal to minus 3x of t. Now, how do I write it in a better way? It will be dx by dt is equal to minus 3x. Fine. I can write it in this way. X dash means what? Dx by dt. Now, as you can see, we can separate it into variable separable form. So this will be dx by x is equal to integration of minus 3 dt. I hope these steps are clear with everyone. You can say if you have any confusion, you can ask anytime. But I hope these steps are clear with everybody. Yes? Okay. So I've got many guest responses in the chat box. Yeah. So x dash, yeah, sure. I'll just tell you again. So the question is given to us as x dash t is equal to minus 3x of function t. So simply writing x dash as dx by dt, which is a function minus 3x. Right? Now doing the variable separable form, where I have to bring all the x terms on one side and all the other terms on the other side. So from here, I got this x term here and I left this minus 3 over here with dt. So I've just separated the variables, bringing x term on one side and t terms on the other side. So we do not have any t term here except dt. So we have just left it with minus 3 dt. Yes. And our next step would be to integrate it. Okay. That is how you solve your differential equation. So next step for solving it, you will have to integrate. So integrating on both the sides, dx will become log x is equal to minus 3t plus some log constant c. This is your simple integration, right? So taking anti-log over here will give me what? X is equal to, now here in this, you have to be very quick to get to recall your trigonometry and log and all such formula, right? Tan and log and all such formula. You should be very quick to recall these formulae. So see, x will become c e minus 3t, e to the power minus 3t, because there was no log term in minus 3t, right? So it will become c into e minus 3t. Now this is our general solution, but here we are also given one condition, that x naught is equal to, that x at 0 equal to x naught. X at 0 equal to x naught. What does this mean? This means that when t equal to 0, x will become x naught. When t equal to 0, then x will become x naught. So now just substituting that in our equation 1, what will it become? X will become x naught equal to c will be as it is, e to the power minus 3t. So it will become e to the power 0. So x naught will become c, right? X naught will become c. So x naught equal to c. Now from equation 1, substituting it back in your equation, what can I say? X will be equal to x naught e to the power minus 3t. So the thing is that in the previous numerical, you were not given any value like here. You were not given any value. So you left the equation at this. But here you are given a value. After solving the equation, you are given a value that when x naught equal to x0. So that means what? When t equal to 0, your value of x becomes x naught, right? When t is equal to 0, your value of x becomes x naught. So when t is 0, we replaced it in the equation 1, that when this t equal to 0, e will become e power 0 into c, and hence x naught will be c. Simply replacing the value of c in your equation 1, you will get x is equal to x naught e to the power minus 3t. So I hope this numerical is clear. Yes? Yeah. Okay. Then let's move on to the next numerical. Fine. So question is, the solution for the differential equation, dy by dx equal to x square y, dy by dx equal to x square y, with the condition that y equal to 1 at x is equal to 0 is y equal to 1 at x is equal to 0 is dash. Right? So now first thing is we have to solve the given differential equation. Then we'll see what this given condition is, right? It's kind of similar to the previous numerical, so that you will have a more clear concept. So I'm given a differential equation. Now let's write it in a variable separable form. So how we can write it? We'll bring all the y terms on one side. So it will be dy by y equal to x square dx. I hope this first thing is clear. The first step is clear with everyone, that we have just simply written it in variable separable form, where we have taken all the y terms on one side and all the x terms on the other side, right? Then our second step will be, yeah, that's good actually when you respond in the chat box, right? So now our second step will be to integrate it. To find the solution, we have to integrate it. So integrating, so dy by y will become what? Log y is equal to x cubed by 3 plus log c. Simple, yes? Now taking anti-log, it will give you what? Y equal to c into e to the power of x cubed by 3. Yes? So this is my equation. So this is my equation 1. Now here I have solved the differential equation, right? Now the second thing is that I'm given a condition that y equal to 1 at x equal to 0. Y equal to 1 at x equal to 0. So using this condition in equation 1, what will I get? Y is equal to 1 when, so y is equal to 1 when x is equal to 0. E to the power 0. So again, we got c equal to 1, right? Replacing this equation c equal to 1 back in your equation number 1. So you'll get y equal to e to the power x cubed by 3. So this is your solution. So I hope this concept is clear.